Wow, I'm a bit nervous. I already said that. Hi, my name is Henning. Welcome to my session. It's about accelerating innovation with KQL. First of all, thank you so much to the sponsors, and thanks to everyone, actually, who is organizing everything in here. So Alex, Franz, Gianni, and I'm super humbled to be here now in person. The second time. Last time was in Amsterdam, which was also a lot of fun. But still, like having kind of a hybrid show, it's much better to see the faces. And yeah, thank you so much. A few words on me. For those who don't know me, I do work for Microsoft, but my actual job is being Professor Smoke. Who knows Professor Smoke? Who knows what that person is? Quite some guys. Okay, so that's kind of really sticky. And it took my friend Avner only 2 years to find out that smoke actually in German means Rauch. So just kind of funny. So if I'm not doing Professor Smoke stuff with Kusto Detective Agency, I'm a principal product manager at Microsoft. So I work out of Germany for a brilliant team in Israel. And we're building Kusto, the biggest data platform at Microsoft. And actually, when Alex and Gianni asked me to present something, and I asked them, okay, about what should I be talking? And they said, whatever, just pick something. So I'm going to start with something, and hopefully it makes sense for you. If you have questions, maybe we take them after the presentation, if it's okay for you. And then wish you a lot of fun. Before we go into Kusto and all about Kusto and the stuff that we are doing, who participated in Call of the Cyber Duty? Wow. And which one did you enjoy the most? Which part of the Call of the Cyber Duty? Yes, which case? The 5th? You should have said the 8th, the one with the graph. Then you would have like 100 points. But those are the guys who actually won, right? They started from 0. There were some experts in their team, but some of the team members that actually started from 0, and they were really very, very much persistent, didn't sleep. Okay, they were eating a little bit, but they finished after 11 hours, which is just amazing, and won $10,000. So it was like super great for us to see those kind of people being so engaged and loving the product and love the game, and just enjoyed doing it. So before we go into all of the details of Kusto, this is usually a slide that I have in every deck. Because first I want to explain what Kusto is, because maybe most of you, as far as I experience this kind of interaction with this community, you're very much focused on the Sentinel and the Defender side. But there's much more to it. So Kusto is actually a distributed database, and it was created for big data, of course. So anything that has some kind of timestamp associated to it, some measurements and stuff. And it was built right from the beginning for high volume, high velocity, different kind of data types. Back in the days, the team had to onboard a lot of Power BI telemetry data as it moved from on-prem to the cloud. And there was no such system at Microsoft who could do that. So they built it from scratch. And those were, what you see nowadays is based on those requirements from the past. It's an analytical database, and most of you know the relational stuff that we're doing. So using summarize, you're doing projection, selection, using where, and all of that. But it has much more. Nowadays, it even has graph as a native engine part of Kusto. It's a cloud platform that's fully managed. So you get it as a PaaS offering. That's something that is called Azure Data Explorer. But you can also nowadays have it as part of Fabric. And in Fabric, it's called real-time intelligence, and in real-time intelligence, it's called Event House. I'm going to talk about this part a bit more. So it was purposely built for timestamp data. So for example, we decided not to support things like transactions. You need to choose what you want to have. Do you want to have high velocity, or do you want to have an asset compliance system like a traditional SQL database? And we decided to go for high throughput and high velocity. And that's what makes it so fast. At the end of the day, it's an interactive system. So if you are sitting in front of your Sentinel, you want to run a query, you don't want to wait hours. So we decide interactivity ends after 1 hour. So, but we hope that those queries don't take that long for you. But sometimes, it can take a bit. But most of the time, it's super fast. It's faster than anything else, any other technology at this scale. And then I thought, when I talk about Kusto, what do I explain to people? It has like a lot of capabilities. The relational ones, the most well-known one, who's used the graph operators in Kusto? Okay, quite some people. Yeah, we were funded by security teams at Microsoft to build the graph stuff because they had the task to analyze attack paths, blast radius, and all of that. And they had to decide, hey, do we want to go with a different graph database on the side, or do we want to have some of these beautiful graph capabilities directly where the data sits? And in my opinion, it makes a lot of sense. And for them too, so we decided to build it. So you don't need to have a second system on the side. If you're dealing with modern system, and nowadays there was a big hype last year for vector databases like Pinecone and all of that. At the end of the day, if you look at what vectors are, it's a dynamic with a couple of floats, sometimes more, sometimes less. But at the end of the day, it's an array. So we optimize the data structures under the hood. We're about to create an index for vectors, and we have things to calculate the similarity using cosine similarity function. And we already proved that it's working with hundreds of millions of vectors to find close vectors quite easily. Time series is something that came right from the beginning, time series functions, anomaly detection, forecasting. Geo is something that is probably in the product since 4, 5, 6 years, mainly driven by customers from the automotive industry who deal with a lot of geographic data. Sequence analytics, this morning, I was so happy to see scan. The scan operator is just such a gem. And when I see the use cases in your scenarios, like finding some specific patterns, some specific sessions, it's super useful and it's great to see it. When it comes to AI, there's probably no slide at Microsoft that doesn't have anything with AI in it, so I'm so sorry for you. So we support MCP, we have our MCP servers, we have NL2 KQL, which we created even before MCP came. And we have the Python plugins. Python is not something that you usually use because you're from the Sentinel era, but actually, what you can do with tools like Azure Data Explorer, you can take your Python code and execute right where the data sits. So on the compute instances from Azure Data Explorer, for example. Let's talk a bit about the family. I'm working in this part of the family. That's the Kusto core. That's one engine that we're developing, and it's used in multiple experiences. The one that sees most of the love at the moment from the larger Microsoft is Fabric for sure. Everything is Fabric nowadays. And in Fabric, it's real-time intelligence. If you're in the Azure world or in the PaaS world, it's Azure Data Explorer, so it's the PaaS version of Kusto. But we're also very creative with names. We also have a container. It's called Kustainer. And it's actually the same bits as being deployed on Azure Data Explorer or in Fabric Real-Time Intelligence. You can also use in a container and develop against it, do disconnected CI/CD scenarios. It's very useful. And on top of that, there's a ton of different solutions. You probably know more than I do. But at least at Microsoft, there's a myriad of products which were built on top of Kusto. A few words on real-time intelligence. Who has used an event house? You? Okay. So it's a different experience, right? If you're on Azure in the PaaS world, you have to pick and choose exactly the SKU that you want to have and how many nodes. In the world of in the SaaS world of Fabric, we allow ourselves opinions. So you want to get an event house, you get an event house, but you're not really sure how many nodes are running, and we don't want you to care about all of these nitty-gritty details. But what we did with RTI is we created a complete new product suite, which consists of things that you might know from the Azure world. So Azure Stream Analytics, Event Hub, Azure Data Explorer, and different other things. Even Azure Maps nowadays is part of it. So what we try to do with RTI, or real-time intelligence, is create one product that is combining all of these and make sure that it works together really, really well. And all of that together on the Fabric platform, so you get the security stuff, the security aspects. You get the one-lake availability, so that all of your data is available by all engines. You get the real-time hub, so that you can just subscribe to events from your corporate. So it's a great product. And in all of my talks, I'm usually talking about the size of Kusto. Because not so many people actually know about it. And usually I just present the numbers, and this time I want to do it a bit different. Who has read this report? You're from the security domain? So it's a report that is produced every year by Microsoft. It's a digital defense report, the one from 2025. And I want you to focus on this number. So Microsoft is working with 100 trillion events or signals daily. That's quite a number. Guess where all of them are stored. And if you look at the slides that are presented at big conferences like the FabCon, you see, okay, so 502 trillion messages per month, ingested daily, 470 petabytes, 7 billion real-time queries per day. Those are the numbers for Kusto, so for the entire family. But let's ask Couscous directly. Anybody knows what Couscous is? It used to be the Kusto cluster of all Kusto clusters. So there was a central cluster which received all of the events from all Kusto clusters all over the world. So we're doing dog food, right? And I don't know how large it was, like 300, 400 nodes, maybe a little bit more, give or take 100, who cares? But this changed. And I just want to explain the infrastructure that I'm going to work with. So in every region, by the way, Kusto, or Azure Data Explorer, is a Ring 0 service at Microsoft, which means whenever we're building out a new cloud, it has to be there, otherwise that cloud is not working. It's not runnable. Network is not working, Entra is not working, nothing works without Kusto. And in all of these regions, we have a central Kusto cluster where all of the other Kusto clusters are emitting their log and telemetry, and that happens in every region. 60, 70 sovereign clouds, government clouds in every region. And then there's a single thing which we call the Couscous head. So you connect to that Couscous head and it's federating the queries to wherever it has to federate. So what Henning, this guy, is now going to do is going to query that Couscous head. And I'm going to present you those numbers from this Couscous head. Okay, so let's just have a look at some logs. Sorry, the numbers are a bit small, but Kusto logs, there are, wait a second, this is million, billion, trillion, 329 trillion rows, and I can query all of them in this query. Now, you remember this digital defense report, 100 trillion? So this query is looking at the data, everything that was ingested in the last 24 hours. This is a live query, okay? Nothing scripted. And it's taking the sum of the row count and it's dividing it by 10 to the power of 14, which is 100 trillion. And let's see how much it is. May demo gods be with me. So this means we are actually ingesting per day 600 trillion rows in Kusto. And in terms of size, remember the 470 petabyte. If I look at the last day, we actually ingested 519 petabyte. But you know why people love to use Kusto? Because they don't have to pay for the 519 petabyte. They're paying for the 45 petabyte, which are actually stored on the underlying disk. So we're highly efficient. It's a distributed column store. So we're able to compress data really, really well. And we don't rip our customers off. We actually let them really pay for the stuff. Come on. I still have to make some money. I have a family. Yeah, and this is also one that I like a lot. I have to explain it. This is looking at the last 5 days, and now I want to find a single cluster which ingested most data in the last 5 days on a single day, okay? So there was one cluster, I don't know which one, but it managed to ingest 6 petabyte on a single day. One cluster, 6 petabyte, which translates compressed to 403 terabyte. So it's not a real secret. Kusto is the largest, I repeat, the largest platform at Microsoft for data, way bigger than anything else. So that's already cool. Who's interested in, make a guess. How many cores on Azure are right now running Kusto? You make a guess. 10,000? Okay, a bit more. 400,000? Somebody? You're not even close. So right now, as we are speaking, it's 8.5 million cores which are running this technology. It's a bit crazy, isn't it? I think about it. So I'm always like super pumped when I look at these kind of numbers, and I just wanted to present it to you because the technology that you're using, it's not a small island that you're working on. So you should feel confident when you're using this technology because you make a good investment in yourself, because this stuff is everywhere. Okay? There's no number at Microsoft that is not correlated with a Kusto query. Just think about it. Okay. So now we dived a little bit into Cuscos and all of this fun. Let's talk about innovation in Kusto. And when I talk about innovation, there are like so many different innovations. It's not, I can't keep it on a single slide or even in a single talk. So I'm only concentrating on the ones that are super large or super important to me. So I'm a very selfish person. So, and if you like want to cluster it into areas, it's compute and storage. Like all big data systems, they're kind of separated. On the compute side, it's something that probably nobody here in this room ever heard before. I'm not going to talk too much about it because it's still pretty much, I wouldn't call it secret, but not too many people know about it. It's Kuiper. Anybody knows what Kuiper is? So there's the Kuiper belt, which is an area in space which comes after Neptune. So it's a vast area in the space, and it's for, we initially created the name. The name Kusto comes from Jacques Cousteau, from the ocean, diving in the ocean of data, and now we're expanding to space. And it's the Kuiper belt, which represents that. So that's a code name. What's behind that, I'm not going to disclose, but at the end of the day, we're going to move away from the current model that we're deploying compute into a very flexible way of deploying compute. At the moment, for example, it takes some time to scale out specific clusters and also scale in specific clusters. But what we like to allow is to have instant scalability, nice high granular workload management. And that's going to be a fundamental shift in how Kusto is being deployed. So that's something that's probably going to come, let's say, in the next 1 or 2 years. So you won't find it anywhere on any slides. That's something that's going to come. Let's talk a bit more about the other things, where I did prepare a slide. Amudai. Amudai, it's Amudai, that's a column or a pillar. That's what you see on this picture, and Amudai is a diver. And it's like all of that is kind of still related to Kusto. It's a diver, and you have a column. You can also interpret it as columnar storage. So what we are creating, you should definitely check out the GitHub repository that I linked here. That's the next version of the Kusto underlying data estate. At the moment, we have something like a column store that is persisted and has some additional indexes. And what Amudai is going to do is it's going to take this and advance from there. And guess what? It's now open source. This kind of format is open source, and the first thing who is going to get it is the new graph persistence layer, and then it will spread across all Kusto. The benefits of it, it brings everything that we have from our existing Kusto shards format and much more. And one thing that's pretty unique to it, it's now also compatible with Iceberg. So you can do a lot of nice things. If something is compatible with Iceberg, you can use it also with other engines, and it's a native file format now of Kusto. It's still going to take some time until it's going to show up, but if you're using Graph, you're going to see it probably in the next couple of months. KQL Graph, last time I did an announcement at KustoCon, and I'm going to do the same thing again. But I just wanted to give you an update what happened since we introduced Graph, or some parts of Graph at last KustoCon. So we made Graph's first-party objects in Kusto. So far, they were only materialized views, tables, functions, and now they are Graph as the next element in Kusto directly. And you can use them as first-party objects, which means there's a model for it, so you can define how your graph is supposed to look like. You can define constraints. You can define as well labels, right? Static labels, dynamic labels. From those guys in the room who know about graphs and probably things like Neo4j, they know how important it is to define the data and define a data model for a graph in that way. And if you want to persist the graph that you defined in your model, you can use something that's called snapshots. So you take a point-in-time version of your graph. Some people are struggling with it. I usually feel in the security domain that it makes kind of sense because people want to work on a stable environment and not something that's changing over time. So if you want to do an investigation on a specific incident, you don't want that your incident data is continuously changing. So you want to have a stable version of the graph that you can also say, okay, this was my incident. I investigated it based on this object, and I'm going to also create my report based on that stable version. So that's what you can do with snapshots. Besides KQL, there are also other languages, okay? One of them is GQL. Who knows GQL? It's the Graph Query Language. It's actually the first language that got standardized since SQL. And SQL got standardized 40 or 50 years ago. Yeah. But this is like crazy stuff. And it got standardized last year in April. And we as Microsoft did a nice move. And we acqui-hired the person who standardized it. He's now working for Microsoft and is now creating this kind of new graph query language and all of its grammar for us so that Microsoft products can use it. And you can use it with your graph objects. You can run GQL. It's pretty nicely documented, and we received really good feedback for it. Now, people like to look at graphs. People like to visualize graphs. It's really, really nice to look at them. Sometimes let's say on the working level, I doubt that they make a lot of sense because you're sometimes getting confused. And somebody who's working with incidents or with threats, they just want to have a list of the most urgent threats and just work on it. But to get a sense of how specific data is laid out, I think it's super important. And people want to look at graphs because then, it creates a lot of creativity and it's whiteboard friendly. So we created also some visualization in a tool that's called Kusto Explorer. This is even a 3D version. We are looking here at the Bloodhound graph for Active Directory with, I believe, maybe 10,000 nodes and edges. And you can nicely visualize it. We have a couple of neat features like those graph layers, which you can use in order to filter, emphasize specific information. So it's a nice tool. If you're not on a Mac, have fun and try it out. It's for free. I need to ask you that question. Anybody ever worked with Graphistry? Olaf, okay, good. So Graphistry, the previous example that I've shown you, and this is true, by the way, for all kinds of graph visualization, they struggle at sizes beyond like maybe 10,000 nodes and edges. Because then your browser, your client, is getting super, super slow. And it's really hard to calculate all of the rendering and the force-directed graphs especially. And Graphistry is doing something that's pretty smart. So they connect directly to an Azure Data Explorer cluster. They get the graph, and then they render the actual graph or do the positioning of all of the nodes and edges on a GPU, on a backend GPU. And the only thing that you're getting is the visualization in your browser at the end of the day. So we are partnering with them because they are also super strong in cybersecurity. And that's now a live example. The previous graph that you've seen was the one for Active Directory, and this one is the one for Entra, so it's a bit bigger. So we're looking here at 800,000 edges, roughly. If you want to do that with a standard D3.js visualization, bye-bye, come back, never. It's just going to explode. And here you have nice tools. You can color stuff. You can zoom out. And again, it's questionable if how usable such tools are. But I'm constantly getting the questions from security researchers. We want to take a look at the entirety of the graph to see some kind of patterns with the human eye. And this tool is very, very powerful. I'm probably a very bad person to present all of that. But you can also go in here and you can search for administrators. Demo gods are with me. I feel it. Feel the tension rising. But you know what? They told me if I reload, everything is going to be fine. It's probably also a Microsoft shop. Okay, see, this is now it's rendering it, and it said lots of standalone nodes. That's why you don't see anything. And then if you want to, okay, let's do the entire demo. I think we have some time. So now you can't see that much. First of all, the edges are not really that nice. So the first thing that I usually do is I change the edge opacity to something like 4%, and then it looks already a bit nicer. And then you can add a histogram. You can say, I'm interested in a specific label of nodes. Okay, and then you can do, okay, I want to have some kind of special color coding. So I pick a color code. I want to have a logarithmic scale. And then if you hover over it, you see immediately those are AZ apps. This is service principals, those blue ones. Here you have users somewhere in green. And then let's see if this one is working. I'm a very persistent guy. Of course it's working. Then you can check, okay, so over here we have an administrator. It's here, this node, and they can see to what this is connected. Security researchers find this tool actually super useful. Okay, so we did an integration with them. We have a ton of really impressive guys that are working in a Sentinel org, and one of them, and that I like to work a lot with, is Andrzej Karpowski. He's a genius when it comes to KQL, and I always have to say this guy is just a crazy dude. And he added a couple of elements in the function library. Function library is something that we as Microsoft provide in our public docs, and you find a ton of stuff there. Here it's cybersecurity related functions. Some of them are also also using graph stuff. I think like the blast radius, node centrality for sure. And they're in active use at Microsoft. So we are using the same stuff in our own code, in our own protection. In terms of queries, roughly since last KustoCon, 300 million graph queries ran. People created more than 30,000 graph models, and 400,000 snapshots were created. That translates into roughly 4 trillion graph elements, or either nodes or edges, which were persisted. And in this period, roughly 7.5 trillion nodes and edges were queried. So it's we never wanted to be a graph database. We just wanted to make customers happy, customers with a K. And it turns out that a lot of customers are actually using us as a graph database. And those kind of numbers, they're showing it. We didn't expect that. It's kind of super successful, but please don't use it as a graph database. It's Kusto, okay? It is what it is, and we don't aspire to be the next graph database on the planet. We just want to make customers happy. Okay, announcements. Yay, now we have GQL, the most important thing, but hey, the entire industry is still on openCypher, so why exclude them? Because it's so easy to edit in Kusto. That's on the next slide. So openCypher is the open source version of something beautiful that was created by Neo4j called Cypher. It's pure ASCII art, if you ask me. I like that language a lot. I have a small little graph database background. I was competing with Neo4j already since 2009. I hate those guys, but I admire what they created with the language. Really, really admire what they created with the language. And openCypher is something that we added because A, it was cheap for us to edit, and the entire ecosystem is still on it. For example, we're talking with Bloodhound guys, with SpectreOps. They have a Neo4j in the backend. And I assume you are going to hear more about openCypher today. But it's now out today, public preview. And why do we do this? Because I mentioned already it's cheap. So when you see the language processing from getting a query string to actually return something to the user, with KQL we get the query string. With graph semantics, we scan it, parse it, create an abstract syntax tree. It goes to the semantic layer, to the optimizer, and then eventually it's going to be executed. with the Microsoft GQL, it works in a way that we get a GQL string, scanner parser for Microsoft SQL based on this grammar. We create an abstract syntax tree for graph, and then we translate that into operators on Kusto itself. And the same thing happens for openCypher. It's just a different grammar file, right? So we also we deploy it in the same abstract syntax tree for graph and then translate it. So whenever, what you should take away from this slide is, sometimes I get questions like, hey, in GQL, do we also benefit from this new Amudai engine that you're going to create? I said, yes. Everything that we are doing here, all of these other languages are going to profit from that immediately, which is, in my opinion, quite smart. Okay, you have to go through that. I'm super sorry. As I said, there's no Microsoft session without AI. I really like that picture, that meme where somebody's standing on the wall and then there's a big tuba, which is pointing towards that person. And Microsoft is doing like Copilot, AI. But if you start playing with MCP and agents, it's a lot of fun. I'm really enjoying it. So I want you to enjoy it as well, as much as I do. So we at Microsoft, we created a few MCPs. One that we are invested the most in, at least from our side that I know of, is this RTI MCP, so real-time intelligence MCP. It allows you to connect to any Kusto. Even though it says event house, it's Kusto, right? It's the same bits under the hood. And all other RTI that's in there. There's also an Azure MCP, which can do pretty similar stuff, but the RTI MCP is better for graph. Recently, I started investing a little bit into LangGraph. LangGraph is tied to LangChain in a way, and it's about multi-agent scenarios and the orchestration of multi-agent scenarios. And what we try to do is to enable mutual learning between agents in a multi-agent system. You want to have a scalable and reliable backend. And at the moment, the checkpointing system that are available for LangGraph, it's SQLite. It's in memory, and it's Postgres. Postgres is a really good option, but I believe in Kusto. So those kinds of checkpointing, at the end of the day, it's a combination of time series and graph data. Both of them now being available directly in Kusto. So you can start, stop those things. You can have human-in-the-loop scenarios. Nice stuff. And then to KQL, that's something proprietary that we created before MCP was there. And we're right now thinking about transitioning it to the MCP tools. But as soon as you go and check out real-time intelligence, you open a query set, so some environment where you can actually execute something. And you have the Copilot on the right-hand side. This is all driven by NL2KQL. And it's doing quite a lot of smart things. And when you look at the precision recall curve, it's doing nowadays an even better job than the MCP tools. And the MCP tools have a much higher standard variation when it comes to accuracy. So NL2KQL is more stable. But eventually those technologies are going to converge. So how much time do we have? 30 minutes, okay. That's good enough. So I'm going to... That's Visual Studio Code. And it's running, it's a picture, it's actually running now in an agent mode. Sorry, it's a bit not so easy to see. But it can try the magnifier, but I don't think that's going to improve much. So I'm using CloudSonnet 4.5, and it's connected to a Kusto environment. Let's just have a quick look. So let's just go to the workspace settings. I like to use it directly from code, so I cloned the RTI MCP. If you like to debug it, it's quite easy to do so. That's the only thing that you need to configure. And then it's going to be recognized by Visual Studio Code. You can start it. I also created another MCP, but let's not go there. And then you can practically start using it. You can ask it questions. tell me about the graphs on the cluster. I'm just going to read it to you. So this thing is connected to the help cluster. On the help cluster, there are a bunch of graphs. So if I weren't already connected, okay, so this is why I like MCP demos, because it thinks it is still connected. It's stuff. I tell it, you should really connect to the cluster. Make no mistakes. I connect to the cluster. Okay, now it works. So what you see here is, for those who have not seen Visual Studio Code, I just give a very brief intro on how this agent stuff works. You have all of these tools. You see here Kusto known services. So it connects now to the right Kusto cluster. Then it's listing the entities. Okay, let me get more details about graphs by describing them. Obviously, there are like 5 graphs in here. So now it's describing all of these entities. We created dedicated tools for that. And now it's getting sample data from those graphs. So if you would have, I don't know, a bloodhound graph like I do have on this cluster, it's looking at them. It's already executing some graph queries and getting now some statistics. And if you want to know what exactly happens here, you can just open it and take a look. So here, obviously, it was running a graph match on a node. It's projecting the labels. It's doing an MB expand because labels obviously is a dynamic of string, and then it's summarizing it and does a count by 2 string of label. It's doing quite some nice job. And it's getting back the result, and the result is, okay, Henning, you have a simple graph. LDBC interactives is a social network benchmark. It's a financial network. It's Bloodhound for Azure and Entra ID stuff. But you know, as you have so much security today, I'm going to do like financial stuff. So I want to know, provide me some details about the LDBC financials graph. So LDBC is a linked database council. Whoever is in graph databases, it's some council that decides which graph database is fast and which one's not that fast, based on some sample data sets. And here it fails. It fails all the time. But the good thing is it also recovers most of the time. I need to fix my queries. Okay, let's see what it does, or what it did. It did, okay, graph match loan. This is, you know, it has been trained with way too much Cypher, this little friend, because this construct is not working. So in Kusto, you have to explicitly do this in your constraints section. But you know, request is invalid, and what we're trying to do most of the time is improve the error message so that the agent is going to do its job. Okay. Now it comes back with a nice analysis about all of the nodes and edge types. To get to know a graph, and you have no clue about what's actually in that graph, I find this super useful. It's talking about a couple of things, giving you a couple of examples. And then once it's done with it, of course, already did this session beforehand. Okay, I'm interested in fraudulent loan guarantee chains. I don't know what that is, but it's obviously something that's in the data. And now it's analyzing it and returning the result to you. We don't necessarily have to wait for this to finish, but I think the point is clear. Those kinds of technologies, they allow you to just get to the data way quicker with natural language, and you still have the option to learn exactly what was created under the hood, which kind of queries. Okay. Kusto Terminal. Actually, I plan to do all my demos in Kusto Terminal. This is like one of our weird developers decided that he hates the mouse. He wanted to have something which is working with the keyboard only. And guess what? He did it. It's working. It's now been released in version 0.1. And if it would have supported things like client request properties, I would have also demoed it. But you know, feel free to try it out. So I was talking about all of these things. So what does it actually have to do with the title of this session? I think the title was something with acceleration and innovation. So I think it boils down to, it's not necessarily the innovation that we are driving in our product. It's the innovation that help our customers to create beautiful products. So that's what's driving us. On a day-by-day work, we see that so many customers are really enjoying it, and they look at it and say, now my business is running faster, more efficient, it's cheaper, I can do my stuff. Like BMW here, or like many others. Sean Bice is the CVP of the Microsoft Sentinel Graph. He is now raving about Microsoft Sentinel Graph, and guess what? He's happy, it's Kusto, I'm happy as well. So bottom line is we are building Kusto and KQL to accelerate your innovation. So everything that you have seen here is based on Kusto, and whatever we are doing, it's going to eventually be available in all of the experiences that you are using, which is quite nice. Call to action, it's never too late. Go and check out Kusto Detective Agency. You need to save Professor Smoke from crypto, from all of these other guys. And we put so much effort and love into it. It's unbelievable, especially Avner and Alex invested so much into it. If you want to learn about the other experiences that you might not already know, Event House, Azure Data Explorer, go for it, try it out. If you're like me and you're into home automation, it's a really good excuse, by the way, to work with Azure Data Explorer. Go and get a Home Assistant and then use the free cluster. There's a direct connection between Home Assistant and the free cluster, and it's so much fun to work with it. And the data just feels nicer if it's not in an InfluxDB. You can also, of course, go for a Fabric trial. Again, almost on time. I'm almost proud of myself. Thank you to all of these sponsors. It's great. I'm so humbled to be here and so proud to be able to speak in front of you. And thank you so much for being here. Thank you. Do you have any questions? You can ask me anything. It's your 3 minutes and 39 seconds. If not, again, thank you.